This is AP Calculus AB. We're going to look at integrating when you have inverse trig functions. These lovely 6 formulas, which are basically the derivatives backwards. So the key to this is trying to figure out which trig function are we talking about and what is u. Because once you know what u is, this is pretty simple. Number 5, this negative here in front clearly means we're talking about one of these 3. This is 1 minus x squared, and if you look here, 1 minus u squared, this is definitely going to be cosecant. So let's just see if this matches up perfectly. Let me bring this down here so we can see this better. So it's probably pretty obvious to you that x squared is definitely in the exact same spot as u squared, which would make x equal to u, which would make u prime equal to 1. So u prime, 1, same spot, that checks out. U squared, x squared, same spot, that checks out. I just realized, sadly, there's a mistake here, fellas and ladies. These should have DUs after them. I don't know what happened. Probably Obama, that's my guess. Thanks, Obama. So if these match up perfectly, then this is clearly cosine inverse. And what's the angle? What is u? Well, it sure looks like it's x. Finished. Nothing else to do. Now that might seem pretty easy, and it is if you know exactly how this works. And well, let's see if we can figure out the next one. The next one has absolute value in it and a negative sign. Negative and absolute value, well, that's got to be this one right here. So let me just copy this so we can see it. And let me show you how I would relate to this here. So I would say that it's pretty obvious what u squared is. It's 4x squared. That's going to make u 2x. You square root both sides. Another route you could go, you could say, well, this is clearly where u is, and u is 2x, so that's fair. Probably would have been a little direct if I would have did that. U prime is equal to 2. And if you look here, we have a little bit of a problem. We got u prime here, but this is not a 2. Well, can we make that a 2? We can multiply this by 2. To counteract that, we have to also multiply it by a half. We have changed the way that it looks, but we have not changed the actual problem. So I'm suggesting that this, if I bring this 1/2 over, and then this integration part here, which is all this, matches up perfectly with cosecant inverse. And what is our u in this case? Our u is a 2x plus your arbitrary constant. You want to try to match up these formulas exactly. If they don't, manipulate them. If they still don't, then you can't do it this way. Number 7, this doesn't have any square roots at all. So that means it's either tangent inverse or cotangent inverse. It's positive, so it's tangent inverse. Let me just copy this down so we can all see it well. Looks like u squared is in the same spot as 9x squared, which makes u the square root, which is 3x. What would that make u prime? It would make that 3. So let's check it out. Is u prime 3? Looks like it directly. Is u squared 9x squared? Looks like it directly. So this is going to be tangent inverse of our angle. Our angle, which is u, is 3x plus your arbitrary constant. Let's try number 8. So far, we only had to manipulate one of them, and that was number 6. Number 8, this has a radical in it, and it's 1 minus something, so that's going to be secant or cosecant. It's positive. This is going to be, I'm sorry, it's either sine or cosine because it's 1 minus something, and it's positive, so it's going to be sine. Let me copy sine down here so we can see it. So let's see. If we set this equal to u squared, and we square root both sides, we're going to get u is 5x to the 4th. So we're thinking that's what our angle is. That's going to make, excuse me, u prime 20x cubed. And if you look, that works out perfectly. U prime is 20x cubed. U squared is 25x. So this is going to be sine inverse of u. We're saying u is 5x to the 4th plus your arbitrary constant. So this is not as easy as it may have looked, or you might be cursing at your screen right now. I apologize either way. So there's 4 examples of how to integrate inverse trig functions.